Hello, thank you for joining us as we share our senior project. My name is Matthew Bluestein, and I'm joined with my colleagues Will Snyder and Will McInnis.
Together, the three of us have used the skills learned from Cal Poly's Industrial Engineering program to create a scheduling support system tool for our client.
Before we begin, we'd like to give a huge thanks to our technical advisor, Dr. Reza Paragabagar, administrative advisor, Dr. Dan Waldorf, project liaison, Daniel Bierman, our client, Marty Sterling, and the entire Northrop Grumman Corporation. Without further ado, let's jump into the problem statement.
The division lacks an efficient system to analyze active projects and make appropriate revisions. The inability to adapt to dynamic project requirements and resource adjustments results in issues such as late completion times and unnecessary labor costs.
Our client is a production scheduling manager. Her role is to ensure the projects she oversees are completed on time and on budget. Currently, the process begins with receipt of multiple files outlining the project, including statement of work, allocated budget, resource facility constraint specifications, high-level timeline overviews, and a top-level task breakdown in Microsoft Project. After receiving these files, it is up to our client, the production planner, to make the decisions regarding allocation of resources, including employees, equipment, and facilities for each individual task in the project timeline, ensuring that these resources are properly utilized and are not in conflict with other tasks within the project or with those in other divisions. In the current state of operations, this information is then entered into an additional offline Excel sheet created by our client to get a better grasp on the project scope. Data including set number, task breakdown, forecasted start and finish are recorded on the sheet. Once the employee specifications are received on a separate sheet, the scheduler estimates how many heads will be necessary to complete the job on time. After this information has been logged, the scheduler is able to compare the current requirement with the number of available heads, the goal being to balance the schedule with the monthly allocation of employees to that project. This is done by shifting certain tasks around the timeline in an attempt to get a delta that is as low as possible without over-assigning employees in an effort to optimize utilization. Task predecessors do not automatically follow suit, so it's important to reference task predecessors in Microsoft Project before any changes are made. Planners must also monitor location assignments for tasks to ensure conflicts within the project are not present. This information is referenced in the same sheet containing employee specifications.
The production planners at Northrop Grumman have expressed concern with this current method of scheduling. Manually shifting these tasks is a labor-intensive process prone to errors. Resource conflicts amongst schedules from various divisions emerge frequently, and it is the responsibility of our client to shift tasks around the timeline in an attempt to level resources and keep all projects in accordance with deadlines.
With all of this in mind, our next step as a team was to hammer down the most important attributes of any proposed alternatives. The key performance indicators outlined by our clients were defined as functionality, data visualization, ease of use, learning curve, the amount of time saved, and the overall implementation cost.
Once these KPIs were determined, our team worked with the client to weigh the importance of these indicators using an analytical hierarchy process. Through research of alternatives and our previous experience in our linear programming and database courses, we were able to narrow the solution down to 4 possibilities: a tool created using Excel, a tool created using Excel and Access, Smartsheet, an off-the-shelf project management solution, and the option to leave the current process as is.
To create the AHP, we first formulated our pairwise comparison matrix rating the KPIs against each other. This data was then normalized to receive a weighted average for each indicator. From there, each solution alternative was compared across the criteria and normalized. The normalized scores for each alternative are multiplied by the weighted importance, yielding a ranking of solutions. After computing a consistency index of 0.039, we can conclude there are no serious inconsistencies among our pairwise comparison judgments. After running through this process, we found that based on the criteria, Smartsheets would be the best solution for our client. However, due to Northrop's security protocol that limits the use of software outside of Microsoft Office, this option was deemed infeasible. After this determination, the results pointed towards the design of a Microsoft Access tool. Our team was then able to get to work on the solution.
Here we can see the dashboard that our manager will be viewing on a daily basis. Information for Microsoft Project is imported by hitting the New Project button, where files are selected and imported first into an Excel sheet to standardize the data, then transferred into the Access tables. This information is displayed in a live subform which can be edited and saved to change the data table. By default, the current day will display with an indication on the calendar and its scheduled activities displayed in the subform to the right. Specific dates are viewed by navigating to the left side of the screen and selecting a dynamic command button populated with the coordinates to the month and year. In this instance, we'll view the project details on January 3rd, 2018. We can see that we have work being done on 2 projects for a total of 8 tasks. The project's duration, along with the employee totals, scheduled equipment, and scheduled locations, can be found in the subform. We see there is a flagged conflict indicating 2 or more tasks scheduled with the same resources. From there, the scheduler can decide if this conflict is acceptable, a task must be pushed back, or if a task can be completed with alternate resources. To view how a task will impact the project on a macro level, we can use this button to navigate to the selected project. Projects can be cycled using the combo box with the total duration indicated here. The core task details display is seen on the left end of the form with additional details such as linked tasks, task resources, and employee details situated here to the right. The client is able to enter information regarding each task in the associated text boxes and append when pressing the update button. Employee information is similarly assigned in the fields below. The header of the page represents the total progression of the project with a breakdown of each subsystem indicated to the bottom left. As you can see, this project is just getting started, but as we indicate completion on the right form, we can see this change reflected in the color-coded progress bars. Once all the necessary information is updated, we can navigate back to the dashboard. The final feature of the tool involves a capacity check of the available employees. Heading back to the beginning of the project in January, we can check to get a feel for the situation when planning with accordance to our available labor. If our client has, for example, 20 employees available, we would enter this information and check the database. The tail end of the month looks fine, with these dates looking a bit underallocated, while these dates look to be right on target with our utilization goals. The beginning of the month, however, is not as encouraging, with multiple dates strained from work overload. Viewing these dates, it appears as if each day is just one resource over capacity. If the scheduler were to authorize overtime or borrow a technician from another division, we should be able to remedy this problem effectively. And it looks like the 15th does not want to cooperate with this demo. When viewing the task list, we see there are 24 employees scheduled on this date. In viewing the problem, the initial solution appears it may be fixed by pushing back receipt of the bus harness by 1 day. In making this move and refreshing the page, our capacity looks level and in adherence to our goals. After making any date shifts, potential equipment, location, and successor conflicts should also be monitored to make sure we have all our bases covered.
In addition to the Excel and Access project files, we will be presenting our client with a technical guide detailing how to use and troubleshoot the decision support tool. The guide will also include a standard operating procedure, as well as a section outlining potential future development of the system.
To quantify the impact of our solution, we conducted an experiment comparing task action speed of our tool with the current state method. For our experiment, we asked 5 participants to conduct a series of tasks comparing the 2 scheduling approaches seen earlier in this video. Subjects were asked to first locate a specific date and report the number of overallocated employees. They were then required to list the tasks responsible for the overallocation. From there, they were to report the start and finish date along with any equipment or location assigned to each task. If any conflicts existed between multiple locations or equipment uses, they must be identified. This process was repeated for 3 different dates. The results of this experiment were significant, with a mean time of 20 minutes 53 seconds to complete the procedure in the current state, as opposed to just 5 minutes 40 seconds when using the Access tool. Additionally, we recorded the amount of time necessary to set up the current state Excel tool when a new project is received. Although this will only occur around 4 times a year, the amount of time required was substantially higher than the 35 seconds it takes to import the information into our database. While it's difficult to quantify these results, we know the average salary for a scheduling manager at the firm is $118,000. While it's difficult to quantify these results, we know the average salary for a scheduling manager at the firm is $118,000. This costs the company on average around $154,000, an hourly rate of $76.60. We also know our client reportedly spends around 1 hour per day comparing project schedules. While our test did not capture all aspects of the scheduling process, the results show that a reduction of time required to find the information necessary to make a scheduling decision will decline. We estimate that our tool will save our client around 20 minutes per day for a yearly savings of $6,391 for each manager implementing the tool in their daily routine.
While the tool was created to fulfill the specific needs of our client, We feel that some adjustments could be made to allow integration with other scheduling managers throughout the organization.
Our team is confident that our client will see significant results upon implementation of the tool. We would like to part with some final thanks to the Cal Poly IME Department and Advisory Board.
This experience has been equally challenging and rewarding. The three of us eagerly anticipate using the lessons learned from this project and our collegiate careers moving forward. Thanks for watching.